Hello, everyone. Thanks for joining us today. We're expecting quite a few people to join us, so we're going to get started. On behalf of the Environmental Finance Center Network, welcome to our webinar on diagnosing wastewater lagoon problems. My name is Tess Clark from the Syracuse University Environmental Finance Center, and in a moment, I'll turn things over to Robert Davies from the Michigan Technological University. But first, there are a few logistics to keep in mind. Today, everyone will be on mute just to ensure audio quality. And to ask a question, please go to the question dialog box on your GoToWebinar control panel to submit a question or a comment anytime throughout the session. We will be saving time for questions at the end of the webinar. You will receive a follow-up email from us afterwards that includes a link to any materials that we cover today and any other information that you may need. A PDF of the presentation is available under the handout section, so you can access that right now and download it for your use during this webinar. This training hasn't been pre-approved for any kind of formal PDH or CDU credit. However, we will provide certificates as a courtesy. We can't guarantee that the training will receive pre-approval or that this training will meet specific requirements. However, we'd love to be able to provide these as a courtesy. Please be sure to attend the entire session and participate in poll questions. You must be registered and using your real name and a unique email address to receive a certificate. We do our best to get those out to you within 30 days of today's date. And if you have questions or you need assistance, please contact smallsystems@syr.edu. Okay, and now for a little bit about the Environmental Finance Center Network. Through training and technical assistance services, we help water and wastewater systems achieve their goals and stay in compliance with clean and safe water regulations. Please note that as part of this work, we offer free technical assistance to small systems and wastewater systems, and I'll share a link in the chat shortly to our assistance form. And here you can see the various centers that make up our network. You can see that our centers and partner organizations are spread across the country for this year's programming. We work together to create solutions to difficult how-to-pay issues of environmental protection and improvement. And on that note, I'll turn things over to Robert. Thanks for joining us, Robert. And you should be able to share your screen in just a minute.
All right, see the presentation on that side?
Yep, looks great.
Awesome. All right, thank you everyone for coming to the Diagnosing Wastewater Lagoon Problems webinar. Before I begin, I'll take a minute to introduce myself a bit further. Oh, come on, slides. I'm Robert Davies. I'm an engineering intern here at the Great Lakes Environmental Infrastructure Center at Michigan Technological University, which is part of the Center for Technology and Training. Also in the room with me is Gregory Pearson, the wastewater systems trainer at the Center for Technology and Training, as well as John Sullivan, the senior research engineer at the Center for Technology and Training. As for myself, I'm a fourth-year civil engineering student at Michigan Technological University with a wastewater focus. And then let's talk a bit about wastewater lagoons in general first. So for today, I'm hoping that attendees will be able to explain causes of excess sludge accumulation in wastewater lagoons, determine appropriate corrective measures for typical wastewater lagoon problems, discuss ways to minimize short-circuiting in wastewater lagoons, explain the facultative and aerobic processes within a wastewater treatment lagoon, discuss methods operators can use to measure and evaluate sludge accumulation, and evaluate some costs associated with sludge prevention and removal. So first, what are wastewater lagoons? So wastewater lagoons are common components of wastewater systems. They rely on natural processes and retention time. They are basically just holes in the ground filled with water, natural pond or man-made ponds that we're using to hold wastewater and process over time. They have very similar processes to something like an aerobic basin and an activated sludge plant, except the reactions happening there over a much longer time and are just very much slower and not as helped along. So Looking at this example of a activated sludge plant, lagoon functions hold very similar functions to the different positions in a activated sludge plant. First are the clarifiers. A lagoon acts somewhat like a clarifier where it allows solids to settle out of solution as well as allowing biomass to accumulate within the lagoon system. They also serve as an aeration basin if you have an aerated system where aerobic respiration is able to happen in this area and the biological processes are able to be carried out to treat waste products. It also acts as a sludge holding area where it has sludge holding, where all the sludge settles to the bottom of the lagoon system, as well as sludge treatment where the anaerobic processes happening near the bottom of the lagoon are able to process that sludge and break it down further so it's easier to manage. So how a lagoon works is basically through natural processes where it splits off into usually 2 or 3 layers, where first your upper layer is a lot of algae and aerobic bacteria producing CO2 and oxygen, feeding off of the different waste products that are in the lagoon. From there, the dead cells from that settles out into the bottom of the lagoon where you have anaerobic bacteria and all your digesting material that happens where you get off-gassing byproducts and things come up to the surface and can get processed further, and it's a nice chain reaction of that. So in an unmixed lagoon system, you typically get 3 layers. The first layer is your aerobic layer, where it's usually about the first 2 feet of lagoon system, and that's kind of your main reactor for the lagoon. It's where you have a lot of pathogen control reactions. There's a lot of oxygen demand in this layer, and in the form of algae, there's a lot of oxygen generation. At this layer, reactions are happening relatively quickly. There's a lot of oxygen present, there's a lot of reactions, a lot of algae, bacteria, everything's here reacting very quickly. As we get further down the lagoon system, we get to what's called the facultative zone, where you get both aerobic and anaerobic conditions. So the microbes in this layer are very versatile, where they allow both for aerobic processes and anaerobic processes to happen at this layer. And it's a transitional layer as you get further down the lagoon, where the oxygen levels are slowly depleting down until you get to the anaerobic zone. The anaerobic zone is your lowest oxygen zone of the 3. It's the digester layer. So there's generation of CO2, hydrogen sulfide, many other gases in this layer just due to the anaerobic processes that are happening. There's nutrient retention in this layer in the form of the sludge layer that's forming, and it helps to break down the sludge layer through the digestion processes. And it's typically your slowest layer when it comes to reactions, because the anaerobic reactions that happen at this layer are simply slower than your aerobic counterparts. Then finally, along the very bottom, the sludge layer is forming. That's where you have a lot of settled solids. It's all of your bacteria, sediment, biological material, anything that the lagoon isn't processing while it's in suspension is slowly settling out into the sludge layer here. It's always going to accumulate over time. No matter what you do, it's going to have something's not getting digested, something's going to accumulate, and it's typically planned for a 20-year removal. That's the typical design length for that. But it's also critical for proper operation of the lagoon system. The sludge layer is holding on to all the bacteria and biologic material. So if something happens to the wastewater itself, where you get in and it wipes out your existing ecosystem inside the wastewater, the sludge is able to help inoculate some of the wastes, so you always have some biologic material and activity within the system. So what standards are wastewater lagoons held to? Well, if you're discharging into an open water, you have a National Pollutant Discharge Elimination System permit, which was formed from the Clean Water Act. And that permit is based off of the susceptibility of your receiving water to take in different parameters. So if your wastewater lagoon is putting effluent straight to a receiving water, this is the permit you're going to be under. So this is a little sample of a permit from a facility. It's split up into 3 different sections. First section has your parameters of what you're being tested on. So there's flow, dissolved oxygen, pH, total suspended solids, the list goes on. Second section are your required concentrations for those required maximums or required concentrations for those different parameters. And then finally, there's the monitoring requirements of how often you have to test for these different parameters, as well as how those different parameters need to be tested. For the different types of sampling that you have grab samples, which are simply just dipping in, collecting one single sample and using that to test. There's a 24-hour composite sample, which is simply putting a water pump in, having it take a certain volume over, say, 1 hour, and then over the course of a day, then you take that water sample and do the tests. Visual is just making sure that something's happening, or there's continuous monitoring. So to run through a quick example of a parameter here, we can look at the total suspended solids in the 4th row of this table, where we're allowed 20 milligrams per liter in our effluent, and we have to test that twice a week in a 24-hour composite sample. So our first question here.
So our first poll question is your facility under a NPDES permit? And you can just let us know yes, no, or if you're unsure, that's okay too. I can see that about 30% of folks have already responded, so we'll be giving you just a few more seconds here. So I'm gonna close the poll in 3, 2, and 1. Last chance, closing the poll. Okay, and in terms of results, over half of the attendees today do have a NPDES permit. 26% say no, and then about 19% are unsure.
All right. So yeah, so with the NPDES permit, it's just something that if you don't have one, it's not the end of the world. It's just something that you have to be aware of what your system can handle in the ongoing processes if you aren't under that permit for what you're putting out in your effluent. If you are under one, it provides a great starting point for all of your data trends for if you have a problem with your lagoon system. We'll go in a bit more detail about the different parameters in the permit now. So first one is the biochemical oxygen demand. That's simply an indicator of the strength of a waste stream. It shows the amount of oxygen that is required to process the wastes that are in a sample. So it's usually a 5-day test, and it's measuring how much oxygen is required by bacteria. So we get our nice little fun Pac-Man bacteria here, where its food is that BOD clump, and it's taking in both the BOD and oxygen to digest the waste and produce, to digest that waste. So these are typically done using 300 milliliter jars, and depending on the sample standard that you're working towards, you put in a certain amount of your water sample and then dilute it the rest of the way before you leave it for those 5 days to measure the oxygen concentrations before and after. So then there's the solids. There's about 4 different ways that you can classify solids within a lagoon system. The first is through total suspended solids, and that's typically done by filtering through a 0.45 micron filter where it captures all the solids, and that's the usual threshold for where you have suspended or you have dissolved solids. The dissolved solids are going to stay in the solution of water, and you can look at the total suspended solids. Total suspended solids can be divided further into volatile and non-volatile, and that's done by drying the total suspended solid sample, putting it into an oven, cooking it at 550 degrees Celsius, and then weighing it again to see how much material has burned off. And that burn off material usually results in it meaning it had organic materials in it and can be further processed by the lagoon system. So one thing to remember with the sludge layer that you're forming, it's kind of like a log in a campfire. Your total solids are the log itself before you've burned it, and the fire is the organic reactions happening within that lagoon system to help process the wastes and treat it to your standard. And what we're looking for with a campfire is it's eventually going to burn down into a nice small amount of ash with some small reactions happening still, but for the most part, it's mostly broken down. And this mostly broken down is representing our inorganic solids, where there's not much that can be done in the lagoon system to break down this material further, and it's as fine as we can get it. What we don't want to see is more of a picture like this, where we're having large chunks of organic material within the ash pit, because that's going to result in the sludge layer accumulating very quickly. There's going to be a lot of material left over, and there's just you're not getting complete reactions throughout this system. So for a lagoon system, there's one parameter that's commonly used is using total suspended solids, the total suspended solids to biochemical oxygen demand ratio, and that can have a few different scenarios. The first is you can have this ratio be less than 1, and that typically means that the sludge layer that you have is releasing soluble BOD into the waste environment. And this is typically from you have a lot of organic material in that sludge layer, and it's just releasing everything. So what you can do to help with this is mixing up the sludge layer to help put some of those organic materials into the solution quicker, and so it's breaking them down much faster and getting more contact time. The other scenario you can have is you can have them equal to 1, and this is typically where short circuiting is happening, and this is where you have just your influent is entering the system, coming into the lagoon, and then leaving almost immediately. It's not having time to get the retention time, get the contact, and process it accordingly. One solution for this problem is putting in baffling into the system, where it's going to force the water across a certain path. So even if it is still going through quickly, you can control the amount of time that it's taking to get through that path better than you can just an open pathway. Then the goal for a lagoon system is getting about a 1.5 ratio from this, where you're getting solids you're getting suspended solids, but you're also managing it with the oxygen demand that those solids have. You're not getting too much solids, you're not getting too much oxygen demand, it's staying fairly constant at this level. And then if you go the other way, you can have it much higher than 1 or 1.5, where you get to 2 or 3, and that's typically a sign of algae overgrowth, where it's kind of hiding some of that BOD just by producing more oxygen, putting in a lot more solids into the solution, and that has to be done. That has to be managed by putting more oxygen, more aeration, more mixing to compensate for that increased load on the system. So when do problems arise for a lagoon system? So the first that comes to mind is permit violations. You always have to remember that if you're violating your permit, you are putting damage into the environment. For both BOD and total suspended solids, you get die-offs if you have too high levels in different ways. So with BOD, if you have a high biological oxygen demand coming out into the water, it's going to suck all of the water, all the oxygen out of that receiving water, and it's going to choke out the fish, wildlife, everything in there is just not going to live in that anaerobic environment that's forming. With total suspended solids, if you're putting a high amount of solids into the water, it's going to block out sunlight, it's going to kill off algae, it's going to put toxins in the water that way through just more algae die-offs and more fish dying and that kind of thing. But problems in a lagoon aren't always violations, and one common example of this is through odors. So I'm from Grand Rapids, Michigan area originally, and near there was a biodigester plant in Lowell, Michigan, where it was shut down after just 6 months of operation due to public opinions about the odor it was putting off. So the lagoon, you may be thinking the lagoon's working fine, I'm making my permit, but it smells horrible. If it's smelling horrible, you don't want to just sit there and let it go because it could result in bigger problems. And odors in a lagoon system typically mean you have an increase in anaerobic activity, which means the lagoon's actually reacting slower than you normally would expect it to be. So we have another question here.
So this question asks, which permit characteristic has to do with the ability of an effluent to impair oxygen levels in receiving waters? So just go with what you know to be true here. This isn't graded or anything, but is it total suspended solids, biochemical oxygen demand, dissolved oxygen, or mercury? And we'll give you a couple more seconds to think this one through. Just keeping you on your toes today. All right, it looks like we have about 60% of people participating. Okay, and we're gonna just give you 3 more seconds. So I'm gonna close the poll in 3, 2, and 1. And here are the results. Looks like 80% said biochemical oxygen demand.
All right. So yeah, so biochemical oxygen demand was the correct one there because that's what's measuring the oxygen demand. If you confused it with dissolved oxygen is the actual measure of oxygen within the water, while oxygen demand is the oxygen demand. So when does sludge cause problems? The biggest thing with sludge is that it's reducing your lagoon capacity. So when it comes to detention time, there's only 2 parameters that are going into your detention time. It's the volume of your lagoon system and the amount of flow that you are having into the lagoon. So if you change your volume, if you cut capacity, you are cutting your detention time because for the most part, your flow for a lagoon system on average is going to stay fairly constant or similar at certain times of the year. So if you aren't managing this correctly, it can lead to a feedback loop where you have more sludge layer. It's reducing your lagoon volume. It's not getting treated effectively. Further decreases your lagoon volume, and it just keeps spiraling downhill like this. So we can run through a little sample lagoon problem here, where we have a 10-foot deep lagoon by 300 foot by 150 foot that's seeing 11,000 gallons a day come into it. And over these 3 lagoons, we're looking for about a time range of about 70 to 90 days for retention time. So we can look at 2 different scenarios. The first scenario is where you just have a 1-foot sludge layer, which fairly standard layer here, and then about 9 foot of effective treatment space. The second cross section is meant to show what a more runaway sludge layer looks like, where you have about a 5-foot deep sludge layer with about a 5-foot effective treatment depth. So for the first cross section, that gets us a volume of about 3 million gallons of treatable volume here. If we divide that through by our flow, that gives us about 27.5 days per lagoon, and multiplying that out through the 3 lagoons that we have, that would get us within our 70 to 90 day time range. However, we look at cross section 2, we only have a volume of about 1.7 million gallons. So dividing that number through by our flow rate gives us only about 15 days in that lagoon. So total, that's only about 45 days of retention time, which is about half of what we were expecting to get out of our lagoon system. So what are some causes of the buildup in lagoon systems? The first is your normal accumulation. Inorganic materials especially are always going to build up in the sludge layer. There's not a whole lot you can do about it short of removing it physically. You need to, but the goal is to minimize your organic materials that are in the sludge layer to prevent unnecessary accumulation. There's also inadequate mixing, where you aren't getting the proper contact time, and then you're getting physical contact with both bacteria, dissolved oxygen, and the BOD for the system. Those are the two big things that are going to cause you to have sludge build up. So this is just a picture of an example of a lagoon with some excess sludge buildup. Some key points from this are some portion of your lagoon sludge should have volatile solids in it, which can be further processed by the lagoon system. And that sludge is displacing volume, reducing your capacity, and reducing retention time. So if you can see that sludge layer like right at the surface, like you've got some problems that need to be handled if your sludge layer is that high to the surface relative to the water. So one solution that can be done for this is putting in aerators. Come in two types. First is diffusers, where they're closer to the bottom of the lagoon system, and they're pumping oxygen up through that water column. Where you have coarse bubblers and fine bubblers, they're doing the similar thing of just, it's like a bubbler in an aquarium, putting in oxygen. It does some mixing through just physically moving the water. You also get surface aerators, which are easier to maintain because they're at the surface. However, they're only circulating what they can reach. So there's less oxygen coming in, and there's less circulation in general as compared to a big system of diffusers across the bottom. So what are some problems caused by excess sludge? First, that we've talked about a lot, is it's lowering your retention time. It's taking up your treatment volume. It's resulting in your incomplete treatment. So you're going to have higher suspended solids. You're going to have higher oxygen demand in your effluent, simply because that material isn't getting processed through as it should normally be. You're going to get some odors that could be happening, where your sludge layer is getting closer to the surface. So you're going to start to smell a lot more of your anaerobic processes that are happening within that lagoon layer, or within that sludge layer in the lagoon. That anaerobic decomposition occurring in the sludge layer is proceeding a lot slower than if it was an aerobic process. So it's going to keep accumulating slowly accumulating over time if it's remaining in this anaerobic condition. And then you're going to that anaerobic decomposition also puts higher ammonia levels into the water as a byproduct, and that's typically one of the common permitting parameters is ammonia levels. So if you have high ammonia level, it's typically a sign of more anaerobic processes happening in the lagoon. And then finally, you could have something called lagoon turnover, causing floating sludge. We'll talk a bit more about lagoon turnover a little later in the presentation, but it's simply where you're getting thick mats of sludge coming up to the surface, and you may have a lower sludge layer, you may have a lot of liquid space, but that sludge layer is coming up towards the surface. So you're getting a lot of suspended solids, you're getting a lot of odors, you're getting a lot of BOD from that unwanted mixing. So this is just a picture of a sludge layer off-gassing that you can see from the water. So that arrow is pointing just towards that bubbling layer, and this lagoon system doesn't have a bubbler system in it. That's simply hydrogen sulfide gases and other gases coming off of that sludge layer. So what are some options for your accumulated sludge? First thing that comes to mind is, well, why don't we just remove it? Well, sludge dredging is relatively common. However, it is expensive at $350 per dried ton. Another problem with just removing it all is you're going to have to take that lagoon system offline for a time, where you dredge up all of that stuff. It's kicking the particles up. It's going to completely throw the environment that you have in that lagoon system out of whack, because all of that settled solids is now in solution, mixing, and much more than you'd want in a normal scenario. There's also putting aeration and mixing procedures in place. where you are providing more oxygen, providing longer contact times for each of the individual particles to allow that volatile organic sludge to break down at a much faster rate. Then finally, there's bioaugmentation, where you're adding more bacteria, more nutrients, and just treating the sludge to help break down, treating the sludge in the lagoon to help break down those organic portions faster without necessarily doing mixing and aeration. So how are we measuring sludge depth? Sludge depth is typically measured by, you know your design depth of your lagoon system, and you can go out taking some sort of measuring device and measure your water depths that you're actually getting from the lagoon system and subtracting the two. So if we know that our lagoon system is supposed to be 9.5 feet deep, and we're measuring the lagoon at 6 feet deep, we know that our sludge layer is about 3.5 feet in total. So what are some different ways that exist to measure that sludge depth? First is a sludge gun, which is an infrared sensor, or that's a sensor on a rope basically. You pull a trigger and it's just going to continually let out cable until it hits that top of the sludge layer and stops. And then you can read the depth off of the cable itself. There's also sonar methods where you can have something as simple as a little fish finder going out and getting sonar depths that way, or you can have a bigger system where you're looking at taking a sonar and mapping the entire bottom of the lagoon system through like a sonar mapping. You can have something as simple as a disc on a rope where you take a little Secchi disc on a string, drop it down similar to the sludge gun until it hits the bottom and you feel resistance on that top of the sludge layer. Measure your string, gives you an idea of what your sludge depth is at. Then finally, there's the sludge judge, where it's simply a plastic tube with a valve on one end. You dip it all the way down to the bottom where it hits the sludge layer. You can both measure it as well as open that valve on the bottom to take in a sludge sample. So these pictures here are just some examples of people using sludge judges. You can see in that bottom of the tube the brown sludge layer that's being collected in each of those pictures. So for a sludge survey, you typically are going to grid out your lagoon and pick different points where you're going to always test your sludge depth so you can get a trend. For a 300 by 150 foot, this one example, it used a 60 foot by 50 foot grid. So it gave you 8 different points where they were measuring sludge depth at those different locations to measure trends and all that. And then at those points, that's where you're going to send out somebody in a boat, or you can make a little GPS remote control boat to go out and measure sludge depths at those various locations. So, and then also something you're going to want to do regularly is take in sludge samples, and the biggest thing you want to do for that, outside of the normal permitting requirements for those, is look at the amount of volatile solids you have in that sludge sample. If you have a lot of organic solids and organic volatile solids in that sludge sample, it means you aren't getting the treatment time that you want from that lagoon system, and you're going to want to do some mixing, you're going to want to aerate the lagoon, and you're going to want to get that contact time up for the sludge. Since that's going to help break that down, it's going to help reduce those sludge levels and bring them down to a more manageable level. So this is where the aerators and the diffusers come in again, where they help mix the lagoon system, they help keep those solids in suspension for longer, they help put oxygen into the system so you have more aerobic respiration to help speed up your processes and just keep that lagoon sludge layer down as much as possible. So another question here.
So here we want to know, is your facility actively doing sludge surveys? So just let us know yes, no, and it's also okay if you're not sure. Okay, Gonna give you a few more seconds so we can keep it moving here. And I'm gonna close the poll in 3, 2, and 1. Okay, and it looks like most people are not doing sludge surveys at 47%, but there's still plenty of you who are. 32% of people are doing them.
So just because you're not required to do a sludge survey, it is useful information to have. So it's just something to consider where measuring the depth, because it gives you an idea of how much retention time you're actually getting out of your lagoon system. So changing gears a little bit here, we can talk about some things that happen closer to the surface. So one thing that lagoon systems can do a lot of is algae, and that's actually a big cause of effluent violations. One study showed that it was as high as 67% of lagoon compliance issues were the result of algae overgrowth. So some algae is expected in a lagoon system. It's basically a pond, but what you don't want to see is a big green like sludge over the top of it like you see in the picture down here. So what are some problems that algae poses for the system? The first is the total suspended solids and BOD in the effluent. So each milligram of algae solids is resulting in about a 0.5 milligram of oxygen demand. So if you're having a lot of algae solids, that's a lot more demand for the algae. You're going to have high amounts of suspended solids and BOD from the algae because algae produces very quickly and it's very small, a lot of particles. And it can actually result in the solids and oxygen demand levels that you have being higher than what's in your influent because the algae gets into the effluent and is actually adding to the solids and the oxygen demand for the lagoon system. So it can also cause some nutrient problems. So algae is going to take in ammonia and phosphorus as part of its nutrient cycles, and it can release it when the cells die off, causing you to have higher levels of ammonia and phosphorus in your system, which both of those are permitting parameters that are common on that EPA permit. It can also be a big driver for odors within a lagoon system. So algae is going to die off naturally through its life cycle, and it's going to have to decay and get broken down. And that decay cycle is usually through an anaerobic process where it needs to get digested and broken down. Then finally, that's going to lead to sludge accumulation, where you're going to get that increase in organic sludge material that is avoidable for that accumulation, but because there's so much more cells, it puts a load on the system and it needs to be broken down through natural processes. So what are some solutions that exist for the algae? The first is simply putting chemical treatments into the water, putting chemicals such as copper sulfide act as an algicide and break down the algae. However, you have to realize that you're putting in chemicals into your water system. So you have to be able to treat, it's could upset your treatment process where if you add too much, kills off the algae completely, and you don't have one of your big drivers for biological processes anymore. And it can also cause regulatory problems if you're using too much chemical, too little, and it's keeping things going into the effluent that aren't supposed to be in the effluent. On a more natural note, it turns out barley straw actually acts as a algae inhibitor. So you can put barley straw over the surface, it breaks down naturally over time, and it actually releases some chemicals that help prevent algae from growing in the first place. If you have algae in the system on a large scale, it's not going to kill the algae off. It's just going to help prevent it from growing and continuing. Then some physical things that you can do is putting shade over the lagoon system. This is done by usually using like little plastic, for lack of a better word, ball pit balls, where you spread them out over the surface and it's blocking the sunlight and starving the algae physically from having sunlight reach it. Then through aeration and mixing is just accommodating that increased load on the lagoon system from the algae. Mixing it prevents the algae from being constantly in contact with sunlight helps kill it off a little bit that way, helps keep those cells in contact with the lagoon and break down more readily that way. And then finally, one unique way is through an ultrasonic algae control system, which is basically putting a speaker on a buoy, putting it in the lagoon, and putting a certain frequency through that speaker that helps damage cells and kills off algae that way. So another thing that can happen in a lagoon system is that can help, that's going to cause issues, is not understanding what's coming in to your lagoon system. So if you're on a sanitary sewer, you're going to get a certain influent all the time. If you're on a stormwater, you're going to get stormwater for a certain amount of time. If you're on a combined sewer, you're going to get both stormwater and sewage, and each one of these has its own unique problems. And it's important to realize what sewer you're on and deal with these problems accordingly. This is especially true for combined sewers, but the surroundings around a lagoon can play a big part in what you are going to be dealing with on a daily basis. If you have like green spaces, if you have a lot of agriculture, golf courses, nice green manicured spaces that get a lot of fertilizer on them, or kept very short grassed areas, you're going to get, if it rains, if you're on a combined sewer system, all of that nutrients that were placed on the golf course are going to wash off. Some of it's going to get absorbed into the soil, and that doesn't reach you. But that nutrient-rich solution from the rain runoff is going to eventually get into a storm drain. And if you're on a combined sewer, especially, that's going to go straight to you. And now you're having more nutrients in your system that you have to manage. On the other side of that coin, if you have a lot of impervious urban area around you, or for the system that you serve, if it rains, that's going to pick up all the brake dust, gasoline, oils, sediments that are all on the asphalt, and it's actually not going to get that infiltration like you get on a normal soil surface, and then you're going to get far more amounts of rainwater entering your system, as well as just more heavy metals, more arsenic, that kind of a thing, if you're having that problem with your lagoon system. Then another thing to deal with is through miscellaneous influent. So if you're taking in different sources of waste from the community, such as septic waste or porta potty waste, that poses its own issues. Well, so for septic waste, you may think, well, it's already waste products, so why does this affect me if I'm putting more waste into my lagoon system? Well, the septic waste is its own treatment process, so it's already going to be possibly already fairly well treated in a lot of dead waste material where you don't have a healthy ecosystem happening in the septic system. And if you put a huge quantity of that into the lagoon, it can put a big burden by having to inoculate it, and it's going to sit for a long time. For porta potty waste, on the other hand, it's going to have a lot of biocides in it, and if you don't manage those biocides or meter how fast you're putting those into your lagoon system, if you take a large amount of this biocide, you're going to completely wipe out the ecosystem that you formed for your lagoon system. So when it comes to controlling influent, the two biggest things you can do, the first is consider adding an equalization basin, which is simply an auxiliary lagoon system. And that's going to help buffer the primary lagoon system from having issues when it comes to having septic or porta potty waste put into it. Gives it some time to let that biocide break down, inoculate the waste coming in. It also serves as a buffer for if you get a large volume of water that come in that was unexpected, it gives it an area to run into and slowly enter in the other lagoon systems without completely overflowing the system. Then another one that's important for everyone is lagoon berms. So the lagoon should have a berm around it to help prevent surface water from getting into it that shouldn't be getting into it. So biggest thing is just controlling the environment as close as you can to what you want it to be and knowing what's coming into it's a big deal for managing that lagoon. Some more problems to consider is you could have thermal short circuiting happening within a lagoon system. So cold water is going to sink to the bottom, and your influent's typically going to be warmer than that cold water. And because of that, it's going to shoot straight up to the surface. It could skirt right across the top and right out of the lagoon system. If you're doing a lot of mixing or have baffling to your system, that's going to help alleviate some of that stress of having that short circuiting. But one thing to note is even with baffling, there's that current that's forming that is the short circuit for your lagoon system, because the areas around that current where it isn't flowing as much are going to stay in that lagoon system for longer. So even with baffling, it's important to realize that you're only treating as well as your fastest particles through the lagoon system. Another problem to consider is getting your effluent contaminated. So your lagoon could be working just perfectly fine, and this is especially true if you have corrugated metal piping, but your lagoon's working perfectly fine, but you're still getting issues on the effluent side where you're getting a lot of BOD or a lot of suspended solids in solution that don't make a lot of sense on your lagoon side. This could simply be happening from having debris trapped in the pipe. So that's what this little diagram towards the bottom of the screen represents is if you have a corrugated metal pipe, you get sludge particles caught in the pipe, water flows over it, kicks out those particles, and that enters your water sample. So it's just important to realize that just because you're having a permit issue like at the outfall, but your lagoon system is working fine, the issue may be you just need to clean your pipe and not so much an overarching lagoon issue. So another question here.
Okay, so here we want to know what type of sewer system is your facility located on. So you can let us know if it's on a combined, sanitary, other, or if you're unsure. And it's so totally okay to be unsure. Just to keep us moving, I'm going to give you just a few more seconds to submit your response. So I'm going to go ahead and close the poll in 3, 2, and 1. Okay. And we have over 71% of folks saying sanitary sewer is where their facility is.
Yeah, so most areas are switching over to sanitary sewers just to stop a lot of the outfall issues that come with those. But yeah, if you're on a combined sewer, it's important to realize that you're getting wastewater and you're getting your the rain storm water coming into your system. That's the biggest differences between the two. So one issue you could have is related to the seasons. Some places, especially like up here in northern Michigan, we get very big swings in our seasons where we get fairly warm, hot summers, and we get really bitter cold winters. Precipitation changes over the course of a year, and sometimes you have tourism seasons or where people leave and go down. And for the case of northern Michigan, people come, leave, go down south for winter, not wanting to deal with winter up here. But it's just important to realize that over the course of a year, your lagoon is going to have different demands accordingly. So if you get freezing winters, this is going to be the biggest diversion from the norm for your lagoon system. You're going to have colder temperatures that could result in the pond freezing over, which means you're going to have less natural currents happening due to the wind. You're going to have lower oxygen content in the water system, and it's just simply going to be less conducive to having those reactions that have been happening during the warmer times of the year. So to manage through this, it's really just maximizing the amount of liquid your lagoon system is going to be able to hold, keeping that sludge layer as minimal as possible before winter hits, and just keeping your retention times in the lagoon system higher. And eventually, once spring hits, you're going to have this huge bounce back from that winter time where you're going to have an increase in odors, you're going to have an increase in oxygen demand, because all of this waste that's been sitting in basically pretty anaerobic conditions is now starting to get exposed to oxygen, is starting to getting into more of your aerobic processes, and you're going to have to compensate for this increase in demand. And a lot of systems have to put in aeration to help compensate for this, especially from that winter to spring transition time. So another thing that's going to happen with your temperature differences over a season is that you can have lagoon turnover, especially if it's an unmixed lagoon system. Lagoon turnover is basically anytime the surface of your water becomes colder than your bottom, and as a system. So the colder water is going to become denser, it's going to drop to the bottom, and it's going to pull all of the it's going to pull out a sludge and all the water from the bottom of that lagoon system, which is basically your entire anaerobic layer, if you're unmixed, up to the surface. And now you have a bit of time where you have a lot of anaerobic processes on the surface. So some problems that result from this are a lot of odors. So all that anaerobic material is now close to the surface. Floating sludge. Sludge is pulled up, you get that sludge map forming, and it's keeping that sludge layer higher. And treatment challenges, all of that's going to result in a spike in BOD, total suspended solids, and a lot of your other parameters are going to spike up when you have that layer switch and pull up to the top. So what can be done is keep your lagoon system circulating. That stops that layering from happening, so you don't have as wide of a temperature difference in the first place. Increasing aeration to help compensate some of that increase in oxygen demand, and just keeping the mixing process going to help prevent a lot of that increased load on the system. So our last question here.
Okay, so here we want to know, what time of year is the lagoon experiencing a large increase in BOD? So let us know if that's mostly happening for you from spring into summer, from summer into fall, from fall to winter, or from winter into spring. And I can see that we have quite a few people already responding. And to keep us moving, I'm just going to keep it open for 3 more seconds. You know the deal. So I'm going to close the poll in 3, 2, last chance. And okay, looks like the majority of people are seeing that, winter into springtime is where they're experiencing a large increase in BOD, but also a good bit from spring into summer.
Right. Yeah, so it's going to be that anytime you're getting that big temperature swing is when you're going to get it. And that could be different all over the world all over the world where you're getting different season behaviors for your local area. So just to wrap up a bit here, got just 4 main points to go off of is lagoons are relying on natural reactions to treat waste. You're not typically putting in large chemical amounts into your lagoon system. Proper mixing and aeration is a big key to keeping your contact time up, keeping your particles moving, and just keeping everything in balance. Reducing your retention time is a big problem because it's going to typically result in less treatment for your solids. If your lagoon design time is already pretty high, it may not be a problem. However, it's less treatment is going to mean more sludge, and that your sludge control is deciding how much treatment time you're getting, and that's your key point to maintain the lagoon system. So I'd like to thank everyone for coming out and attending. Both my email is here, and as well as Greg Pearson's email to get hold of us if you have any questions. I'd like to thank the EFCN for providing this platform and having a lot of training resources available on their website. We'll open this time to have any of the questions that were asked during the webinar to get answered.
Yeah, thank you so much. And just to remind folks, if you were looking to download a copy of the presentation today, it's immediately available for you under the handout section, and you can download that, save it, share it with folks that you think might benefit. And as a reminder, the recording will be posted on our website, and you'll be notified with a link to the recording shortly after the webinar concludes. So we have some really thoughtful comments and questions that have come through, and Greg has been keeping up with them so far. I do want to just quickly mention, oops, sorry about that. We had a great comment come in that just says, I have heard of some operators who actively grow algae or duckweed in their lagoon and then use a pump and screen to remove the algae and thus removing some of the nutrients. Have you heard that too?
I have heard that, and especially with duckweed, I've heard that, and it's just something that it's fine to have a bit of it in. It does provide a Fred's reaction. The duckweed's providing some natural shading so you don't get as much algae, but it's just something you have to know what your lagoon's going to handle, and if it gets out of hand, it's going to completely throw the ecosystem out of balance.
That sounds great, and like a good little, a helpful tool to keep on in mind. And then on the same note, another thoughtful comment is that there are there's legal requirements for pesticide application, and related to the use of barley straw, it might be possible, since it's a less chemical intensive method, that there are some sorts of exemptions for uses of barley straw in a lagoon. Have you seen anything like that?
I haven't heard anything specifically about that, but I didn't do much digging into the barley straw side outside of it has those properties. So just do your research and be aware of what your jurisdiction has for that.
Yeah, that's great advice. And it's always good to know that there is a less chemically intensive option available for when it's appropriate. And then we had another question come in that says, I hear a lot about blue-green algae related to toxic algae blooms. Are those different types of algae that cause different problems, or is that the same thing? And how do you tell the difference?
So that's a bit deeper than my understanding is. I don't know if Greg or John have a comment on that. That's a bit beyond me.
Yeah, yes, a lot of times the differentiating into the different types of algae is more of a drinking water issue. And mainly we're concerned about is the algae expected to impart some kind of taste or odor to the water? And also will it result in disinfection byproducts? And normally what happens in the drinking water source is we sample long before the algae can even be seen. So on a microscopic level, if you see the precursors of some algae cells, and it's determined that we're likely to have an algae bloom because the conditions are right, it's getting warmer, there's some nutrients, then when the operators apply some kind of algicide, they don't have to apply very much because they're catching it early. And now in the wastewater side, we're seeing that maybe a deeper question resting in this concept, where maybe you're thinking, are these byproducts going to cause some kind of problem in the receiving water or interfere with the wastewater treatment process? And I believe that's something that we're willing to do some research on and maybe get some deeper ideas. And if anyone is interested in knowing about that, we can do some research and respond.
That's fantastic. Thanks, Greg. And as someone on the drinking water side, predominantly, when we talk about blue-green algae, often we use it interchangeably with harmful algal bloom, and usually what we mean is that cyanobacteria or the microcystin, which is most often mediated by phosphorus, and we typically find that in a drinking water system that is we see them in late summer, and we do have to often close beaches, implement different treatment options like carbon filtration and whatnot. So that is a big door to open, but a good one to think about. We do have a few more questions, and I think we can stay on just an extra minute or two to cover them, but we won't keep you long. Let's just take one more here. Have you heard of using barley straw for drinking water reservoirs?
I have not personally. A lot of the research that I was doing for this project was more on the lagoon side. I don't know if either of you have heard of that.
I've actually never heard of that.
No. Okay.
Yeah,
So,
we'll have to research that one.
yeah.
And then I have one question is, I have a conventional septic system having problems with flooding due to encroached development with poor infrastructure. What can you guys do to help? That's a great question. And I can let you know now that what we could do is if you reach out to us, you might qualify for free technical assistance through our Building Technical Managerial and Financial Capacity Program. And I encourage you to reach out to us because there might be someone who can help you look into local resources for that. It's different everywhere. Greg, I don't know if you have any other decentralized system tips and tricks up your sleeve.
Well, we'd have to see the particular instance, but I know our senior research engineer, John Sullivan, has helped people over the phone, even to see if there are financial resources. Sometimes, depending on the jurisdiction, there may be some financial resources, and of course, there may be some technical resources to maybe there's an above ground alternative or some kind of other alternative that would allow that septic to function. And basically, it sounds like a high water table. So I think the best route is, like you say, Tess, to actually reach out and find the technical assistance provider that's the region closest to.
Perfect. Yes, and I put a link in the chat at the beginning of the session that has our technical assistance page there. Okay, on that note, I think we have to call it a day here. Any last words, Robert?
Just want to thank everyone for coming out and coming to the webinar. Thank you.
Awesome. All right, have a great afternoon, everybody.